Hi there, this is Miss Brown, and today we're going to have a presentation on organic compounds. Now, what does that mean, organic? Somewhere on your chart, you have a chart to fill in, and somewhere on your chart, I want you to write down that organic means living or was once living. And these compounds we're going to learn about make up all living things. And of course, as high school biology students, we always relate to living things we're familiar with, like mammals and ourselves and larger animals. But this all has to do with all life. You remember, we have bacteria and plants and algae, all sorts of things that this will relate to. Okay, so let's go in our chart. We're going to start with carbohydrates. There are 4 of these. They're across the top. Also, I want you to write they all contain carbon. Everything organic will always have carbon in it. And they're usually bonded to these other elements that we call the elements of life. And the easy way to remember that is CHNOPS. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. So you need to write CHNOPS somewhere. Those are the elements of life. And carbon is number 1. All organic things will have carbon. Now, what are the 4 organic compounds? There are 4 main groups, and they're across the top of your chart: carbohydrates, lipids, proteins, and nucleic acids. And this is a much better way to study if you have the chart to go by so you can compare, see the similarities and the differences to help you get this straight as you study organic compounds. So we'll be starting with carbohydrates. The first one, we'll go straight down this one. So the elements that make up a carbohydrate, carbon, hydrogen, and oxygen are found there. That's where the name carbohydrate comes from. Carbon, hydrogen, and oxygen. And it's going to be in a 1-to-1 ratio. Now the functions, what are they for? These are for quick energy, and they also are used for some stored energy. The energy value is 4 kilocalories per gram, and they make up the structure of organisms. Now keep in mind, you can stop this at any point before you move on. Now, categories and examples. You have monosaccharides, that's glucose, ribose, and fructose. Mono meaning 1. So that's 1 sugar. Those are your simple sugars that are broken down. They're in a very simple form. You use them quick. Then your disaccharides have 2 sugars put together. Things like sucrose and lactose, which is the sugar in milk. And then you have your polysaccharides, and these are much more complex. These are your more, what y'all might call complex carbs that hang with you a little bit longer. The starches, like in potatoes. Cellulose, that's a fiber in our diet. Chitin, that's actually a sugar. It makes up the outside of an insect. It's exoskeleton, that crunchy part. And glycogen, that's found in a large amount in white meat chicken. Now, special properties, they're made of covalent bonds. Some are polar. Some dissolve in water, like sugar. Whenever you see OSC, the first thing should pop in your head is that's sugar. OSC is the suffix for sugar. And then again, cellulose is the fiber we find in our diet. Okay, the basic unit of this is glucose. So for the basic monomer unit, the basic is glucose. Here's the word right here. I'm going around it with my cursor, glucose. And then it asks you to draw a unit. So you need to draw this down there at the bottom. Now on your test, you don't have to have this memorized, but you should be able to recognize it. So how can you recognize this one? It has this ring shape. And as we look at the others, you'll see different ways where you can change them. Or I shouldn't say change, where you can recognize them. I'm sorry. Okay, let's move on to the next one, lipids. You think about fats. Lipids are a fat. And they contain CH and O also. And you may say, well, Miss Brown, how will I tell the difference? It's going to have lots more hydrogen than carbs do. And you'll see that in just a moment. All right, functions, long-term energy storage. It's the stuff you store up and use later. And if you don't use it, you hang on to it, as some of us know. The energy value of this is 9 kilocalories per gram. So fats have double the energy per weight or per mass than carbohydrates. They serve as insulation, keeps you warm. They serve as cushioning. Imagine sitting in a chair all day if you didn't have some fat stores around your pelvic bones. They make up cell membranes. They make up the outside of the cell. And they make up the steroid hormones. things like estrogen and what makes a girl, and testosterone. And also cholesterol belongs in this group. Now, special properties. Fats, examples, first of all, fats, oils, and waxes. Your cell membrane, estrogen and testosterone, and cholesterol. Now, the properties of lipids, they have covalent bonds. They're nonpolar. They're not soluble. You know that. Fats don't dissolve in water. You've heard the expression, like oil in water. They can be saturated. They're solid and from animals. That's things like lard, you may be familiar with, butter. Or they can be unsaturated, and they're liquid. They're from plant sources, and they're a little bit more healthy for you. They're like cooking oil, like canola oil, vegetable oil, sunflower oil, those kind of things. So they're liquid, and they don't clog the arteries. They have still the same amount of energy and calories. They just don't clog the arteries like the saturated fats like lard and butter. Okay, I told you they had lots more H's. So the basic monomer unit of a lipid, and you have to be careful how you say this, fatty acid chain. So be careful how you say that, please. The basic unit is the fatty acid chain. And here's your drawing. So you stop this to have time to draw that in. And I hope you can recognize the difference in that and the basic carbohydrate monomer. Now let's look at this. You hear about this saturated or unsaturated. Which one is it? Well, saturated has all single bonds. So that makes it solid at room temperature. It's a little stronger, so it holds together. Now, unsaturated is liquid at room temperature, and it has this double bond. So that makes it easier to break, so it doesn't harden up, and it's a liquid. Okay, thank you. That's the first two we'll cover. In the next video, we'll cover proteins and nucleic acids.